Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is question number 1.34 from NCERT textbook class 11, and the chapter name is Some Basic Concepts of Chemistry. Let's find the question. A welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 grams of carbon dioxide, 0.690 grams of water and no other product. A volume of 10 liter of this welding gas is found to weigh 11.6 grams. Now, calculate the empirical formula, molar mass of the gas and the molecular formula. So first, let's figure out what the question says. Question is saying we have a gas having carbon and hydrogen. So we can say carbon having H and hydrogen having Y amount. This gas is reacted with oxygen, or we can say burned in oxygen, and it gives carbon dioxide plus water. They gave the amount of carbon dioxide 3.38 grams and for water it is 0.690 grams. So friends, as we already heard the law of conservation of mass, whatever carbon and hydrogen we used as at the beginning, that the same amount we will get at the end of the reaction. So from this concept we will now going to calculate the amount of carbon and the amount of hydrogen. Let's see how. Amount of carbon in 3.38 grams of CO2. That will be, we will count as mass divided by molar mass, which in turn multiplied by 3.38. Now here the mass of carbon, we need to calculate the mass of carbon, so we will put the mass of carbon, that is 12. Molar mass of carbon dioxide, that is 44, and in turn multiplied by 3.38, and we get the answer 0.9218 grams. In the same way, we will calculate the amount of hydrogen in 0.690 grams of H2O. It will be mass, again mass of hydrogen, it is 1, but here at 2 atoms of hydrogen, so we will write 2 into 1, 2, plus molar mass of water is 18, which in turn multiplied by 0.690, and we will get the answer 0.076 grams. Now, the next step is to calculate the total amount of carbon and hydrogen that is present in the gas. So we will calculate, as the gas contains only carbon and hydrogen, so the total mass of the gas will be same 0.9218 plus 0.0767, and this in turn gets 0.9985 grams. Correct? Clear? Now, from this data, we are going to our next step to calculate the percentage of carbon and the percentage of hydrogen. So next step will be the percentage of carbon in the gas, and that will be mass of carbon divided by mass of total mass of the gas multiplied by 100. So Mass of carbon is 0.9218 as we calculated. Total mass of the gas is 0.9985, which in turn multiplied by 100, and we will get the percentage of carbon, that is 92.32%. In the same way, we will calculate the percentage of hydrogen in the gas. So percentage of hydrogen we will calculate by the mass of hydrogen, that is 0.0767 divided by mass of the gas 0.9985 multiplied by 100, and we get the answer here 7.68%. Now this we will going to use to calculate our empirical formula. So calculating empirical formula, we need a grid. So first of all, fill the grid. First column is element. Second column is percent by mass that we calculated. Third column is atomic mass of element. Fourth column is moles of element. Next column is simple molar ratio. Next column is whole number ratio. So let's fill the grid. Elements are carbon and hydrogen. Percent by mass we calculated. For carbon it is 92.32. For hydrogen we calculated 7.68. Atomic mass of carbon is 12. Atomic mass for hydrogen is 1. Now moles of element is percent by mass divided by atomic mass. So here 92.32 divided by 12, and we get answer here 7.69. In the same way, 7.68 divided by 1, we will get 7.68. Now simple molar ratio is the moles of an element is divided by the least of the moles. So here least is 7.68. So now 7.69 divided by 7.68, that we get 1. Again 7.68 divided by 7.68, we will get answer 1. Whole number ratio is also, because simple ratio is whole number, so whole number ratio is the same. When there is some decimal properties are there in the simple molar ratio, then we will make it as a whole number ratio and as a whole number. So now from here we will calculate the empirical formula. Empirical formula of the gas, as we calculated CXHY. So here C values we got C1. So X value we got 1, and hydrogen we put the value Y, and Y's value also we got 1. So now empirical formula is CH, as we are not going to mention 1. So this is the first part of our question, the empirical formula of the gas we got. Now come up to the second question, that is molar mass of the gas. For this we will use the second statement of the question, that 10.0 liters of gas at STP weighs 11.6 gram. So 22.4 liter of gas at STP weighs, now here we put the unitary method, 11.6 divided by 10.0 into 22.4, and we get the answer 25.98, something like that, 98 4 grams, which we will round off and make it 26 gram. And that is the molar mass of the gas. Because as the definition says, the mass of any gas having 22.4 liters is equal to its molar mass. So here the 22.4 liter of gas weighs 26 grams. So this is the molar mass of the gas. Come up to the third point of the question, that is molecular formula. The formula for molecular formula is equal to N into empirical formula. So here first we calculate the value of N, that is molar mass of the gas, which is divided by empirical formula mass. Now molar mass, as we calculated 26, empirical formula mass is the mass of the empirical formula. So empirical formula is CH. So here carbon mass is 12, hydrogen mass is 1. So empirical formula mass is 13. Now we will put in the formula 13 and we will get the answer 2. So N's value is 2. Now directly put it in the formula. Molecular formula is equal to 2 into empirical formula is CH. Now we get C2H2, and that is our third answer of the question. So the molecular formula is C2H2. So friends, question is seen lengthy, but the calculations are very easy, and if you go stepwise, you will never miss the point. So stay tuned. If you like the video, please press the like, share and subscribe button, and don't forget to press the bell icon so that you will get the notification for next coming videos. Till then, thank you.